This video will provide a quick overview of how to create calculated fields in Kirix Strata. It will also show how to use formulas and functions to do various tasks, like cleaning up dirty data. First, we'll go over some calculated field basics. A typical field or column is static. Actions can be performed on it, but the underlying data doesn't change. Calculated fields come into play when you want to create a calculation across an entire table. This type of field is dynamic. It changes as you type in your formula. For instance, you could just type in 1, 2, 3, and it will appear in every record. Or you could add numbers together like 1 plus 1. The calculation changes every time we modify the formula. We can also do this with text. For instance, data plus base gives us the word database. These are trivial examples, but what makes a calculated field really useful is that you could reference other fields as well as use functions. So, for instance, I could reference the field VEN_name in my calculation. Or I could use a function like recno to provide a record number in each cell. Then I can click OK to save. Once I've created my new field, I can easily edit it. Here I'll just bump up the record number by 1. Additionally, I can convert it into a regular fixed field. By doing this, I lose the ability to change the formula, but it does provide other benefits like letting me edit individual cells. Okay, let's explore calculated fields a bit further. Here I have a table of Apple's historical stock prices. So first, we'll create a simple field with the text of the company name, Apple. I'll also go ahead and rename the field, and could also set field type, field width, and decimal places. Now I'll create a formula based on 2 existing fields that shows the daily change in price between the market open and close. To find the percentage change, we'll create a field that references both an original field as well as our new calculated field. In addition, we'll use a function on the date to find out which day of the week the stock price was recorded. While we're at it, we'll just display the abbreviation. And finally, we'll go ahead and capitalize it using the upper function. So that's a basic framework for using calculated fields. Now we're going to turn it up a notch here and try our hand at some more advanced data cleansing. During this next segment, I'll be breezing through the functions I use pretty quickly. But if you ever need any help with a function, it can be found by clicking the Help hyperlink in the Formula Builder. This will take you to the Help manual for more information. Alright, so now we're looking at a sample customer table, but unfortunately it's quite dirty. The streets have spacing issues, different capitalization, and inconsistent use of the word avenue. The city name has been mashed together with the zip codes, and it also looks like we're missing some leading zeros. And in the phone number field, we see different formatting used throughout. What we want to do is normalize this data, basically clean it up so it's formatted consistently. Let's start with the street. We'll first use the upper function to make sure everything is uppercase, and then we'll trim off any spaces on the left and right with the trim function, and finally we'll replace the abbreviation AV with avenue, and there's our clean street field. Now our zip code is currently mashed up together with the city name, so we're going to try to get our zip code isolated into its own field. We're going to do this using the string part function, which lets me break the field into separate pieces based on spaces or another delimiter. So here's the first part, and the second, and the third. Unfortunately, this won't work because we've got city names that are more than one word long, like New York. So we'll have to play with this a bit more. First, we're going to reverse the order of the field, and then we're going to apply our string part function like before, except we'll grab the first part, which is now the zip code. And then we're going to reverse it again to get back to the original order. And because we've got some leading zeros missing, we'll pad these out using the left pad function. And now we've got a clean, isolated zip code field. Okay, now let's tackle our telephone numbers. Remember that some of our numbers have hyphens, others have periods, spaces, slashes, and parentheses. What we're going to do is translate all these different delimiters into hyphens for consistency. First, we'll translate periods into hyphens using the translate function. Then we'll do the same thing with spaces and slashes. And finally, we'll translate the parentheses to nothing, effectively deleting them. And now we've got a nice clean telephone list. Finally, before ending this tutorial, I'd like to quickly explore an important area called conversion functions. These functions let you change the database type of a field, say from numeric type to character type, without actually needing to change the underlying structure of the table. For instance, these sample credit card numbers happen to have a numeric type. So if I tried to use a calculated field to combine the number with the name on the card, I couldn't, because the name, Visa or MasterCard, is a character type. However, by using the string conversion function, I can change the number to a character on the fly. A second type of conversion is from a character type to a numeric type. So if I wanted to convert my zip code, which is currently a character, to a number, I would use the val function. However, you need to be careful with conversion functions because, as you see, we lost the leading digits when we changed to a numeric type. So until you're certain of the consequences, it's often better to change type by using a calculated field instead of modifying the structure of the table in the design view. The third type of conversion is a date conversion. So here I'll use the date function to show the date January 1st, 1970. In addition, sometimes the date will show up as a character type, like the birth field here. Because of this type mismatch, I can't, say, try to find out which people were born after 1970. However, if I first convert the birth field to a date type, our types will match, and then we'll get our answer. Finally, while I'm here, let me show off one last really useful function called an if statement. I'll say, if the birth date is after 1970, then display younger, otherwise display older. And we see the field populated accordingly. This is just one of many other functions that we didn't have time to demonstrate during this tutorial, but you can always learn more about any of them by using the help manual. Well, that was a whirlwind tour of calculated fields and various functions. Thanks for watching, and please check out our other tutorial videos for further information.